Welcome to The Explainer. Today, we are diving deep into one of the most prescribed and, yeah, one of the most debated drugs in the entire world, statins. We're going to break down how they work, what the real side effects are, some of the deeper fears surrounding them, and look at the future of personalized treatment that could literally change everything. So this is the big question, right? Are statins this miracle drug that's saving millions of people from heart attacks, or are they some kind of ticking time bomb causing all this hidden damage? The truth isn't a simple yes or no. It is way more complicated, and the details really matter. So let's get into them. I mean, think about it. Since the late 1980s, statins have been the absolute frontline defense against what doctors call atherosclerotic cardiovascular disease, or ASCVD. That's just the fancy term for plaque building up in your arteries, the stuff that leads to heart attacks and strokes. They are the go-to weapon in pretty much every doctor's toolkit. Okay, so let's get into the mechanics here. How do these little pills actually pull off their main job of lowering your cholesterol? It's actually a pretty elegant biological trick. It's this really clever chain reaction. By blocking cholesterol production inside the liver, the drug basically fools the liver. The liver thinks, whoa, where's all the cholesterol? And it responds by putting out all these little landing pads, these LDL receptors, to grab more from the blood. So it starts cleaning up the bad LDL cholesterol that's already floating around in your system. It's an indirect effect, but man, is it powerful. But of course, an effect that powerful doesn't come for free. No drug is perfect, and it's so important to understand the known trade-offs. So let's take an honest look at the most common side effects people actually report. First up, the one you always hear about, muscle aches. About 7% of people on statins get this. Now, 7% might not sound like a huge number, but you have to remember millions and millions of people take these drugs every single day, so that 7% adds up to a huge number of people feeling sore. Next is an increased risk of developing type 2 diabetes. This one affects a smaller group, around 4%, and it's linked to the way statins can make your body's cells just a little less responsive to insulin. It's what's called insulin resistance. And this is definitely one of the more serious concerns that doctors have to watch really closely. And the third common issue is a rise in something called liver transaminases. You'd see these on a blood test, and they're basically markers that signal some liver inflammation. Now, it's really important to get this distinction. We're talking inflammation, not necessarily a loss of liver function. Big difference. But here is the really crucial context for all this. The number one most common side effect, those muscle aches, they're completely reversible. You stop the drug, and within a week or two, the aches are gone. And for the more serious one, insulin resistance, that is something that can and absolutely should be monitored very closely, way before it ever gets close to becoming full-blown diabetes. So, okay, beyond those common issues, there are these deeper, you could say more controversial fears about what statins might be doing to our bodies on a much smaller scale. And this all starts with our cellular powerhouses, the mitochondria. You see, Dr. Rhonda Patrick brings up a fantastic point. The exact same chemical pathway that statins block to lower cholesterol, well, that pathway is also used to make something called coenzyme Q10. And you can think of CoQ10 as the spark plug for our mitochondria. So the big question becomes, are statins directly poisoning our tiny cellular power plants? And this slide just illustrates the difference perfectly when you actually look at functional testing. With a drug like metformin, which we know is a mitochondrial toxin, you can immediately see the negative impact on performance tests. It's clear as day. But with statins, researchers just don't see it. There's no measurable functional problem. If there is an effect, it's so small that our best whole-body tests just can't pick it up. Okay, now let's go from our cells to our most complex, most important organ, the brain. This is where we find probably the biggest fear of all when it comes to statins, the potential link to cognitive decline. This is a huge concern for so many people. This is it. This is the question that worries everybody, especially people who have a family history of neurodegenerative disease. I mean, we know cholesterol is absolutely essential for the brain. So is a drug that lowers it putting our brains at risk? So what does the research actually say? Well, this part's kind of shocking. While no study has ever been designed to only look at dementia, dozens have looked at it as a secondary thing. And the results? Every single one found that statins either had no effect or maybe even a slightly beneficial effect on dementia risk. And get this, what's even weirder, there was no difference between the statins that can get into the brain and the ones that can't. But and this is a huge but, big population studies can hide what's happening to one person. And this is where personalized medicine completely changes the game. It brings us to this key molecule called desmosterol, which basically acts as a stand-in, a proxy for how much cholesterol your brain itself is actually making. And this is really the cutting edge. For some people, a statin might just push that brain cholesterol production down too much. If their desmosterol level drops below a very specific line, that 0.8 mark, that's when it could potentially become a problem and increase their personal risk.
And this discovery right here, it just perfectly highlights why we have to move beyond this simple one-size-fits-all playbook. Your individual biology matters a lot.
Exactly. As Dr. Adia says, for someone who has a higher genetic risk for Alzheimer's, like if they carry an ApoE4 gene, you just can't use the standard approach. You need advanced testing and a much more careful, individualized strategy. So, okay, if a statin isn't the right fit for you, either because of side effects or because of these new personalized risk factors, what are the other options? What other tools are actually in the toolkit? Well, here are the three main alternatives. First, you've got ezetimibe. It works in the gut, blocking cholesterol absorption, and it's pretty inexpensive. Then you've got the big guns, the PCSK9 inhibitors. These are injections, they are insanely powerful, and they have basically zero side effects. And then there's bempedoic acid, which is a really clever drug that only turns on once it gets to the liver, so it avoids those body-wide issues like muscle aches. Now, the huge barrier for those last two? The cost. They are not cheap. So, here's the bottom line. We have moved way beyond a statin or nothing world. We now have an entire arsenal of weapons to fight cardiovascular disease. The real challenge of medicine today is figuring out the precise combination of tools that works best for each individual person. And that really just leaves us with this final thought. As our medical tools get more and more powerful and our understanding of biology gets deeper and deeper, the focus has to shift. It's becoming less about broad guidelines that work okay for millions of people, and more about creating a strategy that is tailored specifically to your unique genetics, your metabolism, and your life.